Hello, thanks for joining us today for this video guide on how to set up your project within our latest version of Vertex BD Wood. Within this video, we'll be taking a look at setting up a metric project within our Vertex BD Wood framing software. When you first start Vertex BD, you can create a new project from the Welcome dialog box by selecting the New Project option and clicking OK. Alternatively, you can also select New Project from within the File menu. In the New Project dialog box, select Building as the project to use and enter a project ID. The project ID must be 16 characters or less, cannot have any special characters that can't be used in a folder name, and don't use any spaces. In this case, we will name this project Tutorial Home 1. You can add a more descriptive name here in the name field. This can be longer and can include spaces. The Based On section allows you to select a project that you are going to be copying when you create a new project. When you start a blank project, you'll select the template project. Alternatively, you can choose Local Project and then select one you have already worked on using the Browse function. In this case, we will start with a template Z-level project. Once you have completed this, you can click OK. Next, the project data form will open on screen. Here we can enter in information about our project, such as the customer, building location, information about the structure itself, contact information, and engineering data. This information is just there for informational purposes. Once you have entered in the details you require, select OK and Vertex will then automatically open the project on the first level wall layer. The next thing you want to do when creating a new project is to select how many levels will be active. To do this, we go to the Project Document Browser here in the top left. You then click to expand the Settings folder. Do the same again on Drawing Model Pairs settings here, and we then double-click the option for Select Active Drawing Model Pairs. This will then open a list of the available drawing model pairs. The ones which are checked are the ones which are currently active in our project. So, for example, if we want to add a third level, we can check off the drawing model pairs associated with the third level and click OK. The next step is to set your default wall height. You can do that by going back up in the Project Document Browser. Under Settings, then Location and Height, and then double-click 3D Levels. Alternatively, you can right-click in the main window and select Edit 3D Levels here. The 3D Levels dialog box enables you to change the height levels within the project. This interface shows all the height levels in the project, including the ones which are not active. Based on this, you can just ignore the ones that you don't need. The floor type height levels have been set up as main levels and can be changed freely. Ceiling type height levels are sublevels and are located some distance away from the associated main level. The distance is equal to the total thickness of the selected floor system. If the main level changes, the subfloor level will change with it, whilst maintaining that distance. When you add objects to your building, they are automatically constrained to a height level. By default, the bottom of the wall will be constrained to the active floor level, and the top will be constrained to the ceiling level above that floor. Objects like wall cabinets will be constrained by some distance from the ceiling level. If a height level is changed after you start modeling your building, then all of the objects that are constrained to that height level will adjust with it. This makes it easy to modify the building heights later on. To change the height of an individual layer, simply change the value in the height field for that level in the list view on the left side of the dialog box. You can also change floor to ceiling height and floor to floor height by clicking on one of the dimensions in the preview picture. When you change these dimensions, it automatically adjusts all the levels, so you don't have to reset every level if the height of the first floor walls changes. If you want to change the thickness of the floor system first, select Fix Floor to Floor Height if you want to keep the current floor to floor height constant. or fixed to room height if you want to keep the floor to ceiling height constant. Then right-click on the floor system that you want to change and choose Select Floor or Ceiling. This will open up the Floor Selection dialog box. To select the floor, just double-click on the thumbnail. You should see the new name appear in the floor field, and the offset of the ceiling sublevel will get the new value equal to the total thickness of the selected floor system. If your project is slab-on grade, for example, then select a slab floor type for your first level floor system. The roof height level is there just to control the top of the 5th floor walls. When you are actually modeling your roof system, you will be selecting the walls that it sits on, so you do not have to change the height of the roof level for locating the roof system. When finished, click OK to close the 3D Levels dialog box. Then hit Ctrl S to save your project, or alternatively save it up here in the File menu. One more place we can go while setting up a new project is the project parameters. In the project document browser, under Settings, go to Design Settings and double-click on Project Parameters. Before 3D Levels was developed, the default wall heights and floor system were defined in the project parameters. These parameters are still there, but now they just show the values we have set within the 3D Levels. We still use project parameters for several other preferences, such as default window heights and some framing preferences. In this interface, Preview Picture only shows 2 levels, but the sets are constant with the active drawing model pairs. The default window heights are defined in the floor set for each level of the building. The wall framing sets contain the panel break rules, compound corner detail selections, and double top plate laps. If you will be using Vertex BD to generate wall framing and you are panelizing, you can set limits for the minimum and maximum panel lengths, as well as preferred panel lengths. When you start generating wall panels, Vertex will automatically break the walls into panels using these settings. If you are not panelizing, you can use large values for the maximum and preferred lengths so that Vertex will frame each wall as one continuous panel. If you are panelizing a multi-story building and you want the panel breaks to line up vertically through the building, then use large values to prevent Vertex from creating any automatic panel breaks, and use the panel break macros to define the exact locations where you want the panels to break. The macros can be copied from floor to floor so you can get that vertical alignment you require. This will be discussed more in detail in our later wall framing tutorial videos. You can set different values of these framing preferences for the various wall types by selecting the tabs along the bottom and for each level of the building. The default wall libraries only include exterior bearing, interior bearing, and interior non-bearing walls, so we don't have to worry about the other tabs at this point. When finished, click OK and save again with Ctrl S or the File menu. Thanks for joining us for this video on project setup. Stay tuned, as next we're going to look at setting up reference drawings for our project.